Okay, this is paper 5, 9702 51 R52 R53. This is the code. And the question number 1 is designing of experiment. 15 mark for this question. And the second question will be about data analysis. Again, 15 mark. So the total time will be 1 hour, 15 minutes, means 75 minutes. So this is paper 5 of A2 physics. So only 2 questions, one question designing experiment, other question data analysis, 15 marks each, and the total time for both questions will be 75 marks. So before starting this paper 5, we must learn about the linear equation, how to change a given equation into linear form. So first, suppose log m multiplied by n is written, then it can be written as log m plus log n. Number 2, if log m over n is written, then we can write log m minus log n. And number 3, if log is m power n, then it will be written as n times log m. So we have to remember 1, 2, and 3 formulas before starting this paper. And then the types of the equation. Number 1, if the equation is exponential, like n over n naught e power minus lambda t. This e mean is exponential equation. And we have to convert this into the linear form of the equation, mean we have to write it in the shape of y is equal to mx plus c. So for the exponential equation to be converted into the linear equation, we will take the ln log, not the lg log, ln log both side. So n over n naught and ln of e power minus lambda t. The formula for the lg and ln will remain same. So it can be written as ln minus ln n naught. This power minus lambda t will come first, and then it becomes ln e. So ln minus ln n naught minus lambda t, and this ln e is 1. So we can write this equation ln is equal to minus lambda t plus ln n naught. So this is the linear form of the equation, because y is equal to mx plus c, mean when the graph is plotted, t at the x-axis, ln n at the y-axis, its y-intercept is ln n naught, which is positive, its gradient is negative. So we will draw this equation, negative gradient, which is equal to minus lambda, and this is the y-intercept, which is ln n naught. Okay, now the second equation is the power equation, index equation. For example, the question is R is equal to kd power n. So no exponential. It's a power equation. So for this equation, we have to take log both sides, not the not the ln. So LGR is equal to Lg of kd power n. So take log Lg both sides for the power equation. So it becomes LGR, then Lg, this multiply becomes positive plus, so plus Lg d power n. So LGR is equal to log k, and this power becomes multiple n log d. Now it can be written as LGR n log d plus log k. So this is the linear form of this equation, r is equal to kdn, because it can be written as y is equal to mx plus c. So if the graph is plotted between L, G, D, log has no unit, but D has unit meter. So we have to write unit of the D in bracket. And then this is the origin. And here, the log R and R unit ohm must be in the bracket. So look at this. This gradient is positive. Its y-intercept is positive. So we will draw the line like this. So this is the y-intercept, which is the log k. And the gradient of this line is equal to n. This is the second type of the equation. First was the exponential, and the second is the power equation. Okay, now next equation is just the complicated equation. For example, it is r minus r naught times area is equal to rho L. And we have to convert this into the linear form of the equation. No exponential, no power. So we have to rearrange it. Look, it's very simple. We can write r minus r naught rho L over A, and R is equal to rho L over A plus R naught. If the length of the wire is the independent variable, resistance of its dependent variable, then it is y is equal to mx plus c form, where this L is plotted at the x-axis, resistance at the y-axis. So rho over A is the gradient and R naught is the y-intercept. So the graph for this will be length in the meter at the x-axis, resistance at the y-axis. So its gradient is rho over A positive, y-intercept positive, straight line with some y-intercept, which is r naught, and the gradient of the line is rho over A. So this is the third type of the equation. Okay, next, we have to learn about some data, some reading, and its uncertainties. For example, if the question is x is equal to d plus minus delta d, and the question is calculate x square for this, then the x square simple is we have to write d square and plus minus what is the error of the square. Okay, now suppose we have to calculate delta power n, mean the power error, under root error, square error, cube error, then the formula for this is n times delta d and d power n minus 1. So this is the formula when we have to calculate some values for the power and their uncertainties. So delta x power n is n times delta d, or simply you can write it n times delta x into x times n minus 1. So this is the formula when we have to calculate the uncertainty for any power. Okay. Similarly, if the answer is required for the sine theta, look, if the sine theta is 90 plus minus 2 degree, and the question is calculate the uncertainty. So delta sine theta formula is sine of theta plus delta theta and minus sine theta. Suppose this is just theta and we have to calculate the sine theta. So sine 91, but what will be the delta sine theta? So this is the formula, sine theta plus delta theta minus sine theta. And similarly for cos theta, its error, it will be cos theta plus delta theta minus cos of theta, and similarly for tan theta. So if theta is given, we have to calculate sine theta and delta sine theta, cos theta or delta cos theta. So sine theta, cos theta, very simple from the calculator. But the problem is what will be the error in the sine theta, what will be the error in the cos. So this is the formula to calculate the error in sine theta, and this is a formula to calculate the error in cos theta. Similarly, if the question is calculate the log of the value with uncertainty. So we can calculate log from the formula, but what is the uncertainty? So for uncertainty in log, mean we have to calculate delta log. So the formula is log value plus its error, d plus delta d minus log d, which can be written as log of d plus delta d over d, because this minus is actually division in log. So either use this formula or this formula. And similarly for delta n, it is ln d plus delta d minus ln d, or in short, we can write d plus delta d over d. So these are the few formula to calculate the uncertainties. I repeat, if the angle is given, delta sine theta, this formula, delta cos theta, this formula, if any value is given, it's delta d, the value is suppose d, with its delta d, then the error is d plus delta d log minus log of d, or log d plus delta d over d, right? And then delta ln, ln d plus delta d minus ln d, or ln bracket d plus delta d divided by d. Mean first calculate d plus delta d, then divided by d, and at the end take ln. Okay. If the question is calculate uncertainties by using graph, not the formula, but from the graph. So first we will draw the best fit line after plotting the points. This is the best fit line. And number two, we will calculate error scale constant, ESC, And formula for the error scale constant is number of the small divisions divided by difference of the reading on the axis, either y-axis or x-axis. If the error in the y-axis quantity required, then the error scale constant of the y-axis. If the error requires in the x-axis quantity, then error scale constant of the x-axis. So the formula is number of the small divisions divided by difference of the reading. For example, this is the graph. And here the value is suppose 0.2, and after small 10 division, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Here is 0.4. So the error scale constant will be number of the divisions suppose 10, and the difference of reading is 0.2. So it is 50. So in this way, we have to calculate the error scale constant. You can take 20 number of the divisions, 20 boxes, 30 boxes, but number of the boxes divided by their difference of the reading. So I took here 10, so difference of these two will be 0.2. And then this error scale constant is multiplied with the uncertainty of that reading to get the answer. And after calculating the answer, we will draw the error bars of that value. For example, this is the point, and the error in this point is suppose 0.1, and error scale constant is 50. So answer is coming 5. So we will draw 5 small boxes up and the 5 small boxes down. And then we will block this line both sides. So this is called error bar. So after calculating the error scale constant, we will calculate the size of the error bar. And this is the formula. And then we will draw the bar 5 boxes up, 5 boxes down, right? And similarly, we will continue. For example, this last point, its error is suppose 0.08 times 50. So it is approximately 4. So we will draw here 4 boxes up and the 4 boxes down. So this is called the error bar. We will draw all error bars after calculating this value, the size of the error, by using error scale constant and the uncertainty in that value. Then we will join either the top of the last bar with the foot of the first bar, or vice versa, the foot of this, top of this, with the help of the ruler. And this line is a straight line joining the extremes of 2 bars. This last and first, one top, other, and this is worst acceptable line, and this is best fit line. So we will draw 2 lines, best fit line according to your practical method after plotting points, 5, 6 points, and then by using these formula, we will draw the worst acceptable line. Sometime it is called worst fit line, but actually it is worst acceptable line. Now the question is calculate the gradient and uncertainty. So we will calculate the gradient of best fit line and the gradient of worst acceptable line. Suppose the gradient of the best fit is MF and the gradient of the worst fit FW. So what will be the answer? The gradient of the best fit line is actual answer of the gradient, but the difference of the 2 gradient is the uncertainty in it. So first we will calculate the gradient of both best fit and worst acceptable line best fit line answer will be the actual answer for the gradient, but the difference of two gradient will be the answer of their uncertainty. And similarly, we will calculate the y-intercept of best fit line. So that is CF, and we will calculate y-intercept of the worst acceptable line. This is CW. So the C of F is the actual answer of the y-intercept, but the difference of these two is the uncertainty in y-intercept. In question number 1, which is called designing experiment, 15 mark. So first heading, which we have to write in the solution of this, number 1 is definition of problem. And the marks for this, usually 3 marks. Definition of the problem mean a statement will be given. Under this question, we have to read it and we have to find out some quantities. And we have to define actually the problem in this question. Mean, under this heading, first we will write independent variable. From the statement, we will find out the independent variable and we will write here, and this is the 1 mark. Second, under this heading is dependent variable. We have to identify these things, and again 1 mark. And number 3, we have to find a quantity which must be kept constant of this design. And sometimes it is also called control variable, but it's better to write constant of the design. So this is the first heading of all questions in P5, mean the question number 1, designing experiment. So first we will write the definition of the problem, and under this definition, we will write independent variable, dependent variable, and what is the physical quantity which must be kept constant throughout the experiment. And the number 2 is the diagram. This heading will be given in the paper already, and the blank space will be given for the diagram. So first we have to draw the diagram with pencil. No pen. Number 2, we have to use line drawing, not zigzag, straight line. If there's a curve, it must be straight. Line drawing, okay? And then what we have to draw, so first we will draw any equipment, any device, how to vary and measure independent variable. So we have to draw a device which varies independent and device which measures independent variable. And next, how to measure dependent variable. Mean we have to draw a device, right, which tells how dependent variable is measured. And the next, how to keep a required physical quantity is kept, how to keep required physical quantity constant. And then At the end, very, very important, we have to label. So the labeling of all operators. This is very important. We have to write the name of each and everything. Even we have to write the name of the wire. This is wire, this is thermometer, this is anemometer, like this, okay? So usually this diagram carries 2 marks. So the first definition of the problem, 3 marks, then the diagram with the pencil, line drawing, and we have to draw the instrument which varies and measure the independent variable. We have to draw the instrument which measures dependent variable, and we have to draw the instrument which keeps the physical quantity constant, and at the end we have to label each and everything. So this is the requirement of the diagram. And after this, the next definition, the next heading is procedure. So it means we have to give words to this experiment, we have to describe how to perform the experiment. So first, we will write a line about the arrangement of the operators. And then we will explain how to change and measure the independent variable by given operators, operators which is shown in the diagram. We have to give support to the diagram, and then we have to write how to measure dependent variable with given operators. And then we have to explain how to reduce uncertainties in all measurements. And at the last, we have to write how to keep a required variable or the physical quantity constant. So this is the requirement of this procedure, again 2 marks. So in this procedure, we have to write the arrangement of the operators. So just simple statement, operators is assembled as shown in the diagram. How to change and measure the independent variable by the given operators, and how to measure the dependent variable with given operators, dependent, first independent, then dependent, and how to reduce the uncertainty in all measurements, and how to keep the required physical quantities constant. The next heading is tabulation. We have to give a table and try to use 2 lines for the tabulations like this. So table has 1 mark. So here, first box will contain the number of observation. Then we have to write independent variable with unit, and then dependent variable with unit. And then again, this is dependent 1, this is dependent 2 with unit, and then dependent average with unit, and 2 boxes empty, because at the end, we will decide which quantity will come at the x-axis, which quantity will come at the y-axis. So 3 marks for the definition, 2 marks for the diagram, 2 marks for the procedure, 1 mark for this definition. So 2 plus 3, 5, 5 plus 2, 7, 7, and 1, 9. Still 6 marks remaining. Okay, so 3, 2, 2, and 1. Sorry, this is 8. So 7 marks remaining. Okay, after tabulation, the next heading will be data analysis. Usually 2 marks. So the first one is given equation must be converted into linear form. And we have discussed already how to convert it. So we have to write this in this equation, and then we have to sketch the graph. Y-axis quantity, x-axis quantity, and then we have to write after drawing the graph. For example, this is the graph, and its y-intercept is suppose P, and its gradient is Q. Then we have to write the conclusion like if line is straight with gradient, for example, Q, and y-intercept, for example, P, then the given relation is justified. And sometimes in the question, it will be asked how we can calculate this quantity from the gradient. For example, the gradient of any graph is like rho over A. So by using this equation, gradient multiplied by area, we can calculate this resistivity. This is just the example. Sometimes it will be asked that calculates some quantity from the gradient, some quantity by the y-intercept from the gradient. If this is suppose rho over A, then the rho can be calculated by multiply the area of the wire with the gradient like this. This is just the example. So 2 marks for this data analysis. So 8 plus 2, it becomes 10, still 5 left. And the next is safety precautions. So we have to write our personal safety, not of the operators. Any relevant personal safety, okay? Just one. One is sufficient. So 1 mark, not of the operators, safety for the observer, okay? So now it becomes 11, and the last is good design features, or you can write even improvements. So number 1 is usually written about the dependent, how to make dependent variable measurable. And number 2, improvement in the operators. And number 3, improvement in the method of data collection. And number 4, factors which may affect the whole experiment. So 4 marks for it. So 11 plus 4, 15. So in the last, we have to write about how to make dependent variable measurable. what is the improvement, further improvement in the, what is the possible improvement in the operators, what is the possible improvement in the data collection, and factors affecting, surrounding factors affecting your experiment. Okay, so this is all about question number 1. So this is actually the method to attempt question number 1 in P5.